Okay, we continue with the double slit experiment and make some conclusions. First of all, Young's experiment confirmed the wave nature of light. Previous Newton expressed the view as light was formed from particles. We will discuss the wave-particle duality next year when we are doing also quantum mechanics. So wave can behave as light, but light can behave as a wave, or light can also behave as a particle. Yeah, and Young's experiment gives us mean of practical to establish the wavelength of light. Some considerations are made. When conducting experiments for the waving points we can look at, it's easier to measure the center point of the dark fringes than rather the light ones. One should measure across several fringes to reduce the errors, and the wavelength of light should be in orders between 400 and 700 nanometer. Okay, so we can look at what is going to happen when the screen is moved closer or when one of the slits is blocked. It's interesting to know. You can look at the applet and the formula. How should we do that? Okay, now in order for this question, during a double slit experiment the following measures were made to find the wavelength of the light source. Split spacing is given 0.4 millimeters. Fringe separation is given. We use the formula lambda is a times x over d. Lambda is the wavelength, a is the distance between the slits, x is the fringe spacing, and d is the distance from slits to screen. Okay, when you fill it in you will find an answer for a. The wavelength is 550 nanometers, and for the distance 0.9 millimeters. How can we calculate the slit screen difference? If you have done it well, we would get a distance of 75. Okay. Now we're going to move to our last part, and that is the diffraction grating. We're going to understand diffraction gratings to understand how changing the wavelength and slit size affects the transmitted pattern, the fringes, to understand how the diffraction grating equation is derived, and to be able to complete diffraction grating related calculations. Now, diffraction grating is actually wherein we have a lot of openings very close to each other, which means that the light actually shines on multiple openings. Yeah, if you have a CD at home and you bend it a little bit, you will see actually the effect of white light and actually splitting it into fringes into different colors. We also did the experiment in the classroom, remember, with the laser. So, light passing through each slit is diffracted, and they're going to influence all each other. Yeah, the diffracted light wave from adjacent slits will interfere. Okay. Now this all looks a little bit too difficult, but it is not. You only need to know the formula and how the what is the effect of the different parameters if we change them. Now this is an interesting picture. We have purple light, and purple light consists of red and blue light. Yeah, in the middle we keep the purple light, but then the light is going to split up. So let's just consider just the red. Let's say we only have a red laser. Okay, then we will see a pattern we would see at M is 0, at 0 degrees, which we'll discuss later. Then we have M1 a little bit later, and then M2 a little bit above. It's interesting to see also the distance between the blue and the blue and which one is splitted out more, which we come to that later. Okay. Alright. Now, how does the diffraction pattern change with the wavelength? How does the pattern change with the slit distance? Okay, now for A, how does the diffraction pattern change with the wavelength? Well, the angle of diffraction between each beam and the zero order increases with the wavelength. So from blue to red, as we saw in our slide before. How does the diffraction pattern change with the slit distance? Well, the angle of diffraction between each beam and the zero order beam increases when the slit distance decreases. Now, a little bit of an analysis, and actually it's an analysis how each opening interferes with the other when the light passes through. So, each diffracted wavelength reinforces an adjacent wavefront. Wavefront at P reinforces the wavefront at Y one cycle early. In return, reinforces the wavefront R one cycle earlier. And this forms a new wavefront PYZ. You see that? Yeah? And it travels in a certain direction and forms a diffracted beam. Now, we're not going to derive the equation, but you need to know how we get our data. We have D, which is the slit separation. We have to do this in meters. We have our angle. And we have then n times lambda. So the formula is D times sine angle is n times lambda. You can rewrite the formula, but this is the equation for diffraction grating. Okay. The number of slits per meter, n is 1 over d. As d decreases, the angle of diffraction increases. As n increases, the angle of diffraction increases. Maximum order is when we have 90 degrees. That means from here to here. Then we have maximum order, so all the way at the screen. Yeah. And we could rewrite the formula. So we would get d sine 90 degrees. 90 degrees is 1, so n equals d over lambda. Some questions. A laser wavelength 630, just use the formula. Directed normal, a diffraction grade with 300 lines per millimeters. The angle of diffraction for the first two orders. The number of diffracted orders produced. Now, you can use n is 1 for the first one, n is 2 for the second one, and you can calculate the angle. And we can calculate the total number of diffracted orders produced. 4. Question number 2. Light incident normally on a diffraction grater with 600 lines per millimeter contains wavelength of 500 nanometers and 586 nanometers only. How many diffracted orders are seen in the transmitted light? In this case, it is 2, and for the highest order, calculate the angle between the two diffracted beams, and that should be 0.58. And our last question, light at a wavelength 480 is incident normally on a diffraction grating. First order transmitted beams are at 28 degrees to the zero order beam. Calculate the number of slits per millimeter for the grating, the angle of diffraction for each of other diffracted orders. So the amount of slits is 1092, and the angle should be 69.9. Okay, that's the end. It looks maybe a little bit more complicated than it is, but for the double slit, just remember the formula how to use it, and the same for the diffraction grating, and understand what is going to happen when you change the different parameters. Okay. That's it.